the same.
Yeah, I know.
Spin.
Okay. Today we're talking about web technologies. You can say the web, didn't it? Just the web.
Yeah, I thought it was web, I changed
No,
it.
better, because web is a big topic, so yeah, web technology.
You could just cover the whole internet.
Whole internet. So, along those lines, what is the web? The web, what do we mean when we say the web? And then there's no right answer here. It's, eye of the beholder, I guess. I don't know. I mean, writer answers, but
Lots of computers that can talk to each other.
lots of computers that can talk to each other. I like that. Okay. Anyone else?
With an IP address.
Okay. Web. Good. Okay. I think more web pages. I mean, that's internet, I would say, but web. I mean, but that's just me. I don't know. I'll have different answers. Any other thoughts on the web? Are apps part of the web? Are like your thermostat? I don't know. Do you consider that? I guess I initially don't really think of it as that, but like I said, I think of web pages, but I don't think there's a wrong answer for that. Bunch of servers connected to other computers, a set of technologies to load a web page, I guess is what I would say. How's that different than like networking? Thoughts on that? You guys don't know what networking is. That's totally fine if you don't. I think of that'd be like, how do we load a web page? How do we move data? And the networking part is actually how to get that done. What are the protocols that go into that? I teach a class about that 426. So if you're interested in that, you should take that class. But we're going to be talking about web. So we're specifically going to talk about how web pages load. I want to give you a mental model of how all these different technologies come together to do something that we do pretty much constantly, right? We're always loading up web pages. So what's happening behind the scenes to make that all possible? And once you get rid of some of that, the magic or the black box that goes in that, you can start kind of building your own or understanding some of the nuances and how some of these things come together. So here's a web page right here, right? We've all been to this web page. So one of my favorite things to do to kind of start figuring out what a page is to inspect it. I right click on here, this is Chrome, has this inspect. I actually don't know, someone follow along. Is this by default, this inspect button? See this? Everyone see that? Because I wasn't sure if I have to enable a developer thing or not. I think in Safari you have to enable something, but I don't think in Chrome you do.
It's default.
It's default. Okay, awesome. That's
I see it in Windows.
good. Yeah, the inspect thing. I don't, in Safari, I think you have to do like something in the developer, you have to like enable something, but let's not focus on Safari right now. Okay, Chrome. That pops up this little thing right here. Anyone's used this before? Okay, some of you have, some of you haven't. Okay. So what a default shows you, oh, you want to change the lights? Is that what you're? Yeah, that's smart. Okay, default shows you what it's got the elements tab right there. So it's going to show you the source of the website. This is HTML. We'll get to that in a second. They got a console. Oh, that's interesting. Someone's pretty fast, like do something. So console, you can run JavaScript in here. It shows you what JavaScript's going on. So that's console. We got sources. So let's see what goes into making this web page. You can look at CSS, JavaScript, all sorts of kind of various things. Network, performance, lots of cool things here. This is like its own kind of debugging utility. It's really powerful if you're ever doing web development, this console. But before we get to that, before we dive deep into what these things do, I want to show you kind of just the root of what like HTTP is doing. So every time, now it's implicit, but there's this HTTPS right here, or HTTP on a website. What does that even mean? Well, HTTP is a protocol to transfer data back and forth from a computer to another computer. It has its own kind of nuances to it, but that's it. It's just how do I get data from the server, google.com, to my computer? So one way to kind of dispel some of this magic is to use a command called curl. There's other commands, but curl is a great one. It comes pretty standard on most computers. Curl C URL, it will download the source of the image without doing any of the processing. So let's paste in this URL right here. I'm going to do the -v flag for verbose so you can see a little more detail. It's not on by default. Make this a little bigger for you. Okay, spit out tons of stuff. Let's kind of go back up to the top and see what's going on. Okay, yeah, I see you. 3-1. I guess we go away. Okay. Let's see here. So this is the command I ran. So it shows the stars. That's the debugging part. So it's showing the TLS stuff, handshake. Maybe we can ignore that. What I want to look at right here is it's sending an HTTP request right here. So that's me saying, hey, can you download this page for me? That's the HTTP part. That's the request part. And then it comes out the response. You see the little arrows. It's kind of showing you you're sending it to the server, and then the arrows go the other way. The server is responding to you. So yeah, that was a successful request. Here's some metadata about it. And finally, right here, here's the actual page itself. So this is happening all under the hood. Every time you go to any website, this is all magically happening. You're sending this request, you're getting a response back. And then here's the response. In this case, we're getting back. It's HTML. It's got lots of stuff going on, lots of things that are not very clear to see in this little console window. So what I hope to answer for you today is how do we go from this? And what's cool about HTTP and the web itself is that this is ASCII text. This is literally what gets sent over the internet, over my Wi-Fi connection, is all of these characters. But what's confusing to me about this is how do we get from this ASCII mess of HTML tags to this page? That's what I hope to kind of help you understand in this lecture, is what's going on behind the scenes. And just for a little context, this curl request is very similar to in my web crawler, the request.get. Remember that command I ran? You probably don't remember, but that's okay. It's similar. It's the same thing. Curl does that just through command line, but we could have done a request.get and print out the contents. It would be the same contents here. Remember, we scraped the website for links. Okay. Any questions on that? So that's how do we get to that? That's what we want to answer. So let's talk about HTML itself. HTML is a markup language. And so it's based on XML, which is a very beautiful language if you've ever looked at it. No, it's terrible. It's ugly. It's all based on tags. So everything has tags around it. So a message has an opening tag and a closing tag, things like that. So HTML is very similar. It's a specific version of XML. So everything, I want to look at here. This has like highlighting. So you see these tags, so there's a body tag, opening and closing tag. We won't go into the specifics of what makes the HTML page, but you kind of see right here, it needs an opening HTML page, a head and a body. We can start seeing all the different things. What's really cool about this is you can kind of highlight different parts of it and see what went into this. Like, okay, how do I change this Python? Okay, I can find it right there and see what was HTML that went into that. Okay, cool. Dig in and it highlights it for you, all the different parts of it. So it's really fancy, this tool. So HTML is got these tags around it, opening and closing tags, ways of describing what the web page should contain. Yes.
Do your dev tools go bigger?
Is that better? Bigger still, or?
That's probably fine, yeah.
Okay. But what it's doing is describing what the page should, I don't want to say looks like, that's something else. What the kind of the semantic meaning of the page. Is this part of a table? Should this be bolded? Should this be underlined? But it actually doesn't go into how it should look. That's up to some other job to do. But one thing that we'll talk about later, CSS. But one thing that HTML page can have is embed other assets in it. So it's a page that can link to other things. It can link to links, right? That's one thing it can link to other pages, but it also can link to things like images, things like fonts. Trying to think of what else it can link to. CSS, style sheets, and JavaScript. Those are the big 5 things. It can link to other things as well. But so let's go to body, no head. So here we see a link right here saying, when you download this page, also download this font right here for us, and then download this font too, and this font, and then, oh, here's a style sheet, download this as well. So what your browser is doing, that curl is not doing, curl just gets one page and calls it good. What your browser is doing is it gets this page, and then it looks through all the parts that it needs to say, well, what else do I need to get to make this page actually look good? It says, okay, well, I need to get this font right here. So it goes off to the internet and gets that font, and then goes here, what do I need? Okay, I need to get this font. Okay, I need to get this JavaScript file. Okay, I need to get this style sheet right here. It downloads all these different things to then present your page for you. So make it format this way. Look like this. So at the end of the day, it's really just HTML, but it's all the other assets that make it look good. And so we actually can show you that right now. Go to network, it's my favorite tab. When I refresh this, it'll show us all the connections that had to happen and all the requests that the browser had to make this possible. One thing I love about the Chrome tool specifically is it has this button right here, which I always have enabled, called Disable Cache. Sometimes browsers are too smart for their own good, and they'll say, well, I don't have to get this asset because I know it's just cached here locally on my machine. So I always disable that because it makes it harder to debug. That's great optimization. Definitely you want that on all the time, but when you're trying to debug these things and kind of view what's all being requested, you typically want to turn that, have it disabled. Let's run this. Around me, I have it filtered. So all this stuff. So we have the first page. And then after that, we have all this other stuff. And it shows you a cool timeline, how it got done. So just to make this one simple web page, there's a lot of different assets, 23 requests it had to do. So your one request, then all of a sudden spawn 23 other requests. So they'll go download everything it needs to, all the images, all the JavaScript, all the fonts to make it look how it looks to us. Any questions on that?
Maybe just like a sample, if you go back to the schedule or to the web page, like, oh, maybe I'm getting mixed up. We had those little icons. Sorry, that was on a different web page where we were getting the like font awesome icons.
Yeah, so let's dig into some of what these things mean. When you're doing web development, there will be three major components. There will be the HTML itself. So that's here, the /schedule, and we can show the headers and the response. But then also can preview it for us, which is really fancy. So this is what it would look like if there was no CSS, there's no images. This is what the page HTML would look like rendered by the browser. But then the browser smart enough to say, let me go get these other things. So then there's something called CSS, Cascade Style Sheets. This is the way to describe what your browser should look like. It's a whole different way to program things. It's very used to it. Normal programming languages is not typical. It's more declarative of, hey, this tag should have this attributes of color, border, and stuff like that. I'm trying to find one that I actually wrote. That's what it looks like. And so it's telling you what color should everything be? How should everything be placed on the page? It's the style sheet. And then the last part of the other big technology is JavaScript. And that's our typical programming language of like, how do we quizzes.js, for example. I don't know who wrote that, but it's got functions, it's got semicolons at the end. That's our typical programming language type of thing that we're used to. Those are the three big technologies involved with web. And then you'll see images as well. Here's the logo. It had to download separately and place it in the right place. Okay. So I don't know, does that surprise anyone? All the things that go into making a web page, like just that one simple web page all of a sudden has 23 requests behind the scenes. That's, to me, it's amazing how fast it all gets run. And if you've ever been on a slow connection, you'll see that it's not that fast. In fact, we can actually do a slow connection, which is another cool feature of Chrome. Say, what did it look like on slow 3G? Let's run this again. So this way you can optimize because how your page looks, depending on loading the right things at the right time. Much slower. It's still loading. No transmitting.
20 seconds plus to load the page.
What's it downloading right here?
What point does it time out?
The logo.
Big 750K, it's almost a megabyte for that logo?
30 seconds.
Why is that logo so
Get the
big?
logo. I don't know.
Still going.
Yeah.
Just do SVG.
There's a whole subgenre of like how to optimize web pages, which is a big deal because if Google knows that if it takes more than a certain amount of milliseconds to load your page, it'll leave for some other page, and so that can lose you money. But we're not in the business of doing that, so we won't talk about that. Okay, so let's dig in. I guess we talked about HTML a little bit already. One thing I do find people get confused with, though, often is HTTP and HTML. Those are two things that go together often, but are not anywhere near the same thing. So here's HTTP. It's HTTPS up there. That's a way to transmit data back and forth between computers. So you can transmit whatever data you want. can be binary, it can be GIFs, it can be JSON, whatever you want to transmit. But often on a web page that's used to transmit HTML. I think people get confused because they both start with H and both relate to web technologies. But HTML is a way to describe a document. It has no way, there's no idea of how to transmit data back and forth. That's HTTP's job. Okay. So then CSS, yeah, we talked about that. Anyone have experience with like JavaScript, CSS, and HTML? Let's talk about JavaScript a little, because that's a big deal. We'll talk about, yeah. Well, actually, before we get to that, I want to show you a diagram I created. This is how I like to view it, kind of in terms of what a browser's doing. So first, something causes it to download an HTML page. You clicked a link, you typed something into your web browser, you clicked on, ad on Google, whatever, you're getting HTML. What that HTML then does is points to other assets, things like JavaScript, CSS, images, fonts. There could be more than this. I just listed kind of the 4 things I could think of off the top of my head. And it could actually link to other HTML, and these can link to other things. And so it could actually have a lot of things it links to, as we saw 23 things on that simple page. But eventually it collects up all that stuff and then it renders it. What I mean by rendering it is it means it puts it all in the right place. It executes the JavaScript, it replaces the font, the system font with the font that you wanted. It puts the images how you wanted them to be, and okay, put them in the top left corner, make them this size. It renders it. And then that's what you see on the web page here. It's been all rendered, it's been all downloaded and rendered. And then you go ahead and click a link and it does the whole thing over again. So, okay, I'm gonna click a link here. Now it has to load that HTML page for what's that link for? Okay, and then okay, now I need to download all the JavaScript for this and all the CSS. So all that stuff is happening behind the scenes. Now, often that going back to that little checkbox with caching, your browser will be smart enough to say, well, hey, this page, all these pages have the same style sheet or have the same images in the top left or have the same JavaScript. I can just cache that. It hasn't changed since I last downloaded the page. So I don't have to go out and get it every single time. So it can speed things up a lot faster by having things cached locally on your computer. Any comments on this this figure? These are all retrieved using HTTP. So the first one's retrieved, and then all the other assets are retrieved as well.
So forgive me, you may have mentioned this before. I'm just asking: is the browser doing the rendering for
Yes.
this?
Yeah, and that is a whole area of black magic that like I put tip my hats at browsers, because it's like a hard job, because you want to do it fast, you want to do it reliably and consistently, but you also, web is an interesting place because anyone can host anything you want there, malformed or otherwise. So like a GCC compiler can be really rude and say, sorry, like your program's not formed a syntax error. But on a website, you can't really do that. You have to just try your best, because you don't want to like not show someone the website that they requested. And so it has to deal with a lot of junk of people doing things wrong, and it tries to have to figure out, so there's a lot of heuristics and say, well, did they really mean this instead, and figuring all that out. So, and trying to do it as quickly as possible. I mean, I don't know if you follow this, but every time Apple has a new operating system, they always talk about how fast their JavaScript rendering engine is, and then Chrome always says, oh, ours is faster for this. And so it's definitely an arms race for who can process this and render this the fastest possible. And often the JavaScript is the bottleneck, because we wrote that, us humans that aren't very good at this stuff. This stuff is more of just how fast does it take to get it, and the browser can process it really fast. The JavaScript is hard because it's has to be executed, and there's certain steps that has to follow. Great question. Anything else? Any other questions on this? So in a nutshell, this is what's happening. Every time you click something, it's doing this loop. Make sense? Pretty simple. I mean, each one of these boxes is complex, but the kind of the general idea is pretty simple. Okay. So what's the deal with JavaScript? Let's talk about that. So here we have, well, one nice thing actually, by the way, is we can filter out by these different assets. So what's all the JavaScript? So this one page has a lot of JavaScript to it. Kind of crazy to me. CSS, it has this many CSS pages, images, media, font, doc, all sorts of things. So you can filter out by that. Okay, so JavaScript, correct me if I'm wrong, but my understanding of how JavaScript came to be is we could have static web pages, but wouldn't it be great if pages weren't just static. I mean, really where the web kind of came from is like, can we replicate print, you know, like sorry, not web page, newspaper. It'd really be great if we could like have a newspaper that's digital or a magazine that's digital. That's where CSS came in. It's like, oh, we can place these images and cool in line with our text and be really fancy with how it looks. So that's, to me, the genesis of the web was partly just to do that. Say, well, can we have articles but are hosted online rather than on a newspaper and print? But that's like, well, computers are capable of doing really cool things. It'd be kind of just lame just to have a static page. Can it do more? And that's where JavaScript came in and said, well, yeah, we can do more. Why don't we let people write programs that run on the browser and make pages interactive? So when you hover over something, it blinks or it does something cool. And you know, so that's where it comes from, is how can we make web pages more interactive? And CSS has taken some of that stuff, but things like this is actually written in CSS, but some of the things that JavaScript usually did got moved over to CSS because it's so popular, the cover state. So that's kind of where
An
JavaScript.
example of the JavaScript if you want on this page.
Where?
So if you go over on the left and, well, I mean, like, just go back to the web page and you like expand the OpenFPGA CAD one,
Okay.
and then you refresh the page and you come back, the same ones are expanded, even though like it has to remember what it looked like the last time you were at this web page. And so it saves it, the JavaScript saves in a cookie, and then you'll notice when you reload the page, it re-expanded it quickly back out to make it look like it did the last time you were here. So I don't know, I had to learn enough JavaScript to do that, but
Very good. Yeah.
that's the only one I've ever written, so.
And because like the HTML is still the same, but it's just, yeah, how are you presenting this to the user? So like you said, it quickly has to do it, right? It's not, doesn't like it come expanded, it comes all contracted and then it has to quickly.
Yeah, it's the same web page for all of you, but all of you might have different ones expanded when you visit it, so.
I forgot about that. I remember that, but now, yeah, that's cool. Nicely done. And why I want to focus on JavaScript, because JavaScript is kind of a big deal. There's a lot of development going into it. A lot of people use it. You'll see a lot of job postings for you know, being a JavaScript developer. So at the end of the day, what you want to do with JavaScript typically is you want to control the web page. You want to change some state about the web page. They call it the DOM, the document object model. That's this right here. Go back to here. This is the DOM, and we can modify it. And we get, you know, what's cool is Chrome lets us do this live. So let's inspect this. We can go in here and say like, oh no, let's change this to like it hello world. And I can change that. And if I go to this page now, look, it's different. I mean, this is only local. As soon as I refresh it, it goes away. But that's kind of what JavaScript's doing. It's like, let me go in and find this HTML and change it in a certain way. So that's something that, you know, Dr. Goers just described. Saying, well, these are all collapsed. Let me kind of uncollapse this based on some, you know, global state that's been set in a cookie somewhere. So that's what you think of as like JavaScript's job is to say, here's the DOM, here's kind of this web page. What can I do with this? Interesting. Can I change the colors of something when I just detect that the mouse has moved, or can I you know, modify something in some way?
When I was a student, I wanted to get like my tax documents from the university. And when I went to the website, in the dropdown, they didn't have like last year's tax documents yet. But I'm like, well, maybe they're actually still there. Maybe they're actually available behind the scenes. And so I went into DOM and added last year to the dropdown list. And so then I selected last year and I hit submit, and sure enough, that document was there already waiting. It just wasn't public yet, but it's kind of interesting. By just changing things on the front end, you could sometimes get at places you're not supposed to.
I will say that JavaScript is a wonderful tool. It's a great source of awesome things. It makes web pages feel very interactive, like apps. I mean, think of something like, you know, the Gmail app. It's so powerful in that it feels like you're not using a web page. You don't have to do a reload every time you go to email. It's all behind the scenes. But JavaScript is also a source of a lot of pain and agony of ad blockers and analytics and things like that. You know, because there's programs running on your browser, that means anyone can write those programs. And you can do all sorts of things like tracking where people go and how long they stay on a web page and where their mouse is, and follow people. And then you use the same JavaScript between different web pages to kind of figure out who you are as a person. Say, oh, okay, well, they went to this web page and they're supposed to be this person on Facebook. And so JavaScript is a really great thing, but also a really bad thing in my opinion. I think it can be used for bad stuff like tracking people. to sell them ads. So I think JavaScript is worth knowing about for sure. But one thing I want to make clear is that JavaScript is running locally on the browser. And why this will be important in a second, I'll show you, because there's kind of two different ways of thinking about a website. But it's running locally here on my computer, the JavaScript. That's important to remember. You've heard of Node.js. Maybe you've heard of Node.js. So that's JavaScript that runs on a server. Why that's a big deal is because people are lazy and they only want to learn one programming language. So they say, well, can I do all my web stuff in JavaScript? It'd be great if I could do my server side in JavaScript as well. I already know JavaScript. And so that's where Node.js came from, is can we reutilize all the skills, all the libraries, all the effort people put into learning JavaScript on both client and server. So let's talk about what I mean by client and server. But just to distinguish, Node.js does not want to run on a browser, it's running on the server. Okay. So a web browser, let's see here. This here. A browser consists of, a transaction between a website consists of two parts, right? A browser and a server. I'll be specific that I mean browser here. We could generalize it, but later, and a server here. There's two parts here. So the question is, where do we process information? Where do we execute logic and reason about that? And just be clear, a server is just a fancy word for just a computer running somewhere. It could be my laptop, could be a server. Your phone could be a server. That's not usually what we do, but it could be. But typically, when I mean server, I mean some computer running somewhere in a data center that's always on, that's always waiting for requests. Where the browser isn't always waiting for requests or responses. You can close your laptop and go home and open it back up. Your browser kind of can move around. A server is usually stationary, one place, always waiting to receive a request. So my question is, who should process the data? Let's take a step back and say, well, why do we want to process data? Where does this data processing come into it? As you think about extending web pages, it's the idea of cool interactions and making web pages more expressive and more dynamic. You start having to say, well, how do I process data? Something like Dr. Goder's example is like, well, I have to get some state about the click, the expansion state of each of these things. And I have to save it to disk, and I have to read it from disk, and then I have to change my HTML to reflect that. So as soon as you start wanting to have cooler web pages, you start have to worry about processing data. Things like login state. Are you logged in or are you not logged in? Things like what else? Fetching dynamic content. Maybe it loads a page, and then by doing something, it loads more page without reloading the whole website. Anyone familiar with CMSs, content management systems? That's a good example of something. So you go to a website, a blog, one of my favorite, The Verge. It's a tech thing. People are writing websites, are writing articles. They're not like writing the HTML. They're just writing the article part of it. And then a content management system is the one that takes those words and those images and the title and puts it into HTML for you. It's all based on templates typically. And so these all have a very similar pattern to them, right? It's got, okay, here's the title, here's the subtitle, here's the author, the date, and then the article and images inserted in. So it's not like they're writing that every time by scratch. They have a template they're using that lets them just insert that logic in there. So that's a CMS. And so I want to walk through a couple of different types of ways of dealing with servers and how to process data. So we'll start with the simplest approach where there's no processing of data. That's what I would call a file server. I'm going to be a little loose with my terms here. This makes sense to me, but I don't know if it makes any sense to anyone else. But what I'm showing here is a file server. You have a browser, over HTTP, it gets a file, and then the server gives you the file. So the server has files on it, you request it and get it back. That's a file server. So let me show you that. Oh, let me, works connect to server. I'm going to connect to my J drive here. Might not be familiar with this, but Kadem actually, you have dedicated personal web storage, where you can host web pages from your J drive, which is really cool. So in your main root, there's a www folder. You put files in there, and then you go to a certain URL, you can load that file. So let's load this file right here. I will go to et.byu.edu tilde philipl / that's my my KDM network name, and then test.html. Cool. So what's running behind the scenes here is that it's just set up. Request this file as if you asked a friend, like, hey, can you send me that file? And it sent me the file. And here is the file test page. We can look at that file. It's not complex at all. It's just an HTML page with the title being test page and the paragraph. We could change this. We could say, well, it's just hello world. But if it isn't HTML, does the browser still handle that? Let's make sure we actually save it. There. No. Sorry, typo. That's unfortunate. Okay, let's do that. Okay, so it can deal with HTML, it can deal with raw text. If we gave it an image, it could download that. So this is just acting as a web server, a file server. Go back. We, through HTTP, are requesting a file, and it's giving the file back, and the browser's rendering it. Pretty simple, right? So no processing going on here. That's kind of how the internet started. It's just static files that we just request, and we read the article, and cool, and we're done with it. No real interaction here. So let me start thinking. Well, yeah.
The bootcamp page, a file server?
Yes, it is. I would say yes. That's a whole different. I mean, static site generator is a little different.
Sure, but
I would say
because we're not,
we're not doing anything dynamically on the server. Like I said, my terms are a little loosey. So that's the file server. Then you get into what the next generation is, like a web server. Like, well, this server, it would be really great if I could do some processing here based on the request, maybe a context of the request. Is this person logged in? So what will happen is you send a request through HTTP. It does some checking over here. I guess I didn't put the subsystems here. Maybe it checks the database. Say, hey, is this a user I know about? Have they been here before? Other information, and it processes some requests through maybe PHP. Anyone familiar with PHP? We're all too young for that, maybe.
Where is it checking those requests? Like, where we go to mention cookies, like, is that where it would store whether or not you're logged in, or?
Yeah, cookies are a little different of a topic. Cookies are, how to describe it? It's something that the server gives to you that then you give in every request. So that's how the state is maintained. Typically, this is a good principle for computer engineering and computer science in general. You want to not have state as much as possible. State makes things really messy. And so one of the ways that web has solved this problem is give the state to the client. So the server, it doesn't remember anything about you until it receives a cookie. So it sees a new client, says, okay, here's a cookie so I can remember who you are. And it gives the cookie to the person. Then to follow cookie protocol, every time you make a new HTTP request, it should also send the cookie in that request. And so be like, who are you again? And then it says, oh, okay, cookie, now I understand who you are. You're this person with this login. Yeah, you're logged in, you're good to go.
Okay, and a file server wouldn't.
Yeah, it wouldn't really need that because a cookie implies that the server is doing something with this information and processing it. So that's
File is giving you files, right?
exactly. And I will say you can combine these together. I'm not completely separate. You can be a file server and a web server at the same time. And often these are all together.
and in my little collapse menu thing, I was never sending the cookie. I was just storing it locally. It was just a way to store something on the browser side.
Yeah, and I would say that's probably not cookie, it's probably like local storage, which there's a whole mechanism for storing things locally in
I think
JavaScript.
it was a cookie. I don't know.
And I mean, we can look at cookies. They're not particularly hard to look at because where's my Chrome? So you can see here, go back to our network page, we can click here and it'll show us the cookies that are associated with this.
Aha.
So this is- Okay, so PHP is a programming language that lets you do this. It's kind of the first ones. Ruby on Rails is another one that's popular. Flask. There's lots of ones. I would never use PHP now, just to let you know. But that's when I think of web servers, I think of PHP. So I found example code online and I wrote some PHP that I've never done before. So let's show this.
So it's old and out of date now. People don't use PHP.
And that's the first one I use. I pretend a lot of
You
people.
want to use PHP here?
Disabled it for security reasons.
I would not be my first tool unless you're receiving legacy software that uses PHP. It's It's interesting programming language. It's got some, so, but what you're doing in this case, PHP, is you intermix it with HTML. It's kind of interesting. So here's my HTML page, very similar to the other one, but now I have some PHP code. They've got their own special tags. Say, hey, when you get to this tag, so a server's going to look this in, it's going to read all this data and say, let me look for this PHP tag. And say, oh, I found a PHP tag. Okay, what am I supposed to do? And then you start writing a program here. In this case, I'm going to echo out this string and I'm going to echo out the time. So I'm going to process that all on the server, then spit out HTML.
You might put in information that only the server knew, I guess.
Yeah. Was tests. PHP. Did I spell something wrong?
You do the underscores you have in there?
Oh, I just test .php, sorry. .php. Okay. Nothing that exciting. If I refresh the page, it is updating the time. You all see that? Let's look at this HTML, see what's going on here. Look at this. We'll see. For us, from the client, it's just HTML. So we didn't necessarily know that the server processed this data. We didn't know what's happening. It just gives us HTML at the end of the day. And so there's nothing, we can't actually look into the logic of the PHP server to know what it did to decide this. There's anything secret going on or anything like that, because it's all on the server, nothing from our client. We only receive HTML at the end of the day. We can kind of tell there's something going on because it's .php, so we know there's some kind of processing most likely going on. But there doesn't have to be. This could be just pure HTML and it would have been fine as well. Let me see here. So
Saying you don't have to have the extension PHP? Even if it's HTML.
no, I think no, I meant like this. You could have just HTML and the PHP page. I don't know if
Okay,
it works
okay.
that way. I could be wrong. So what this, I think what the extension is telling you is like, oh, if someone requests a PHP file, go first run it through the PHP processor, get it all to be HTML, and then send it to the client. So it's got an extra step in there. An extra step could be really fast. It could be really slow, depending on how much processing. Okay. Any questions on that? So that's a web server to be kind of pure sense. To be a web server, you don't have to be PHP. I just put that as an example. It could be Python, it could be Ruby, it could be Java, enterprise Java. Web servers are a big deal. It could be anything, any programming language, substitute what you want in there. But I just put PHP as an example. But the key is it receives an HTTP request with some state, it processes the data and returns back HTML.
So did you say it could be JavaScript or?
It could be Java script, it could be, but I said Java, but it could be Java script as well.
So if I go to Netflix and it says, here's your recommendations based on your profile, that's like this. Okay.
It could be like this. There's actually better ways of doing this. So actually we'll talk about that in a second, what it's doing. Okay, but then it's like, well, we got this JavaScript tool. It's really great and powerful. It'd be really cool if we could do other things. So this is, sorry, to be clear, this is server-side processing. All the processing is being done on the server. Servers running logic, say, okay, are you logged in? What's your recommendations? All this stuff, processing. I know this example is really boring because it's just getting the time. I can imagine it was doing cooler stuff like checking the cookie or checking the weather and based on the weather telling you to have a good day or not, or it could be doing all sorts of things you want a programming language to do. But that's server-side processing. Okay, well, we have JavaScript. It's a great tool. Why not just do more than just simple animations and simple kind of interactions? Why don't we do more with that? So you say, well, let's not just return HTML. Let's also return HTML and JavaScript, which is more akin to what this website is doing. This the boot camp website, I guess. It's receiving HTML and JavaScript, and then the JavaScript's making it more rich, the experience. And so just to show you what kind of stuff, it sounds like we've already shown you a little bit, but yeah, no, not PHP. Okay. So this is the test, same as the first example, but if you wait for it, JavaScript then kicked in. I made it wait that long, and now change the page. It's updating the page. And not only that, now I'm putting the time, and I'm updating it dynamically. On the server side, I had to refresh the page every time I wanted to update the time because it's all happening at the server. But now I'm doing this all client side. It's running on my browser here, and I can, nice formatting here. And it's all happening, so it can happen locally. If we inspect this, you can see kind of what's going on here. Well, so so this is the exact same thing that my example one was, but then I added a script part to it, and I wrote a program to then change things. So I get what the current text of the H1 is, and I modify, add the with JavaScript, and then I put things, various things here. So I'm taking the document object model and modifying it, remember whatever I want with it. So lots of libraries to help you with this. I'm using jQuery in this example. And then I also, lots of code to get the date and time.
Lunderkin?
Yeah.
Sorry, off topic, but for like various libraries in JavaScript, do you just have to use the ones that are like guaranteed to be on most browsers? Or are there even libraries in JavaScript?
There are some things that come standard on JavaScript that will be browser specific. Well, those aren't libraries. I mean, I guess you could maybe call the standard library. It's more of just like how JavaScript was implemented, but pretty much everything else is you tell it what to load. So
Oh, yeah.
we're loading. So I want JavaScript jQuery, and so I provide jQuery.
And then anything server side, you can install any necessary libraries to do said processing.
Yeah, if it's on the server, you control that. Yeah. Just as a tangent, if we blow this up, JavaScript has this weird behavior to say, well, let's minify everything, because sending things over the wire costs a lot of time potentially. And so rather than writing JavaScript really nice and clean and good variable names, there's services that will take your nice and clean JavaScript and remove all white space, because white space is not required in JavaScript, and replace all your variable names with random variable names that are much shorter, so that it makes it a lot smaller and unreadable. And so this is jQuery minified. They did that to save those couple of bytes to send over the wire, so that's not much faster. And so that's just a habit that people tend to, you'll see minimized version of lots of different libraries. Fun to read, fun to debug. So what it's doing behind the scenes is it's loading the page. Remember my rendering loop, right? It loads HTML, says, okay, what else do I need to request? Okay, it says, oh, I need to request this. So it downloads jQuery, and then it executes jQuery. So now jQuery's all been set up. And then from here, it now executes my script. And now my script can utilize jQuery. It's just a library, but it can utilize it because it comes after it. If we if we put these tags in a different order, then bad things would happen, because I'd be using jQuery before jQuery is actually run. Okay. So this is all on the client. My web browser is running this right now. Yeah. Let me bring it up. I'll show you. One fun thing, if you're ever trying to debug JavaScript, is you can run things here, JavaScript, like console.log. This is a test. And it'll run that. And so you can say, well, what is, like, can I do that? Okay, so that's the symbol for jQuery. So I can look at what does jQuery mean, and you can actually, it shows you what it returns. So it's a REPL, remember the Python REPL, but in your web browser, so it's a way to debug your code that you're running in JavaScript. And so we can run, we can check out certain state of things and execute some JavaScript if you want to. So that's kind of a nice thing to have there. Okay. So going back to this, it'd be really cool if we could put these two things together, right? And so, sure, let's put them together. Why don't we do some things on the server and then give all those things, and the rest of the things do it on the JavaScript side. But as a developer, you have to decide which one you do, where you do it. Do you do it on the server side, or do you do it on the client side? Do you do it on the back end or on the front end? Those are different terms. Or are you a full stack developer that does it on both? That's typically what those terms mean: front end, back end, full stack. It's the whole thing. So this is kind of where we were stuck for a long time, and this is how I imagine like Gmail was written, kind of a combination of some server-side processing, but a lot of client-side processing to make the experience really smooth and very app-like, so it's all running it. Oh, I should say that JavaScript behind the scenes can make more HTTP requests on your behalf, which is a powerful idea. So saying like AJAX, anyone heard that term AJAX? That was a big deal when that came out. It's like from JavaScript, we can make a request, get more content from a server. And so we can load one page and it can do all the stuff behind the scenes for us. Okay, so Ajax is coming out, JavaScript's becoming popular. Well, then another thing happened that made this more complex is so far, everything we've listed have all been web specific, HTML. But I don't know, with the iPhone, with Android, they know how to render HTML. I guess the web browsers do, but what if I'm building an app? I want to be dealing with web technology. I'm building an app, I'm building something custom. So if I'm getting the data back in HTML, that's going to be a huge mess for me. I either have to parse HTML or it's just not the right option. And so while this is happening, also more diverse type of devices are coming out. You have a modern app that maybe means native. So we could say is, okay, well, sure, an app, we build a different server then, right? We just have another server right here that talks directly to the app. But I don't know, that costs a lot of money, that costs a lot of time. If you fix a bug here, then you have to go fix it in this other server, magical server exists. It'd be really great if we can have one server that talks to all of our devices. Ideally, it'd be actually great, and this is a true principle for all computing, if we could decouple the view from the controller. The logic, the server-side processing, if we could decouple that from the specific technology that's being used to render the image, that'd be really great. Whether it's HTML, whether it's Swift and Cocoa on Apple, or whatever Android uses to render its UI. It'd be really great if we could decouple those. And so people started designing servers in a different way now, what I would call an API kind of format, where instead of returning something that's specific to one type of technology, why not return something that just works across all technologies, something like JSON. And once you do that, then you let your JavaScript interpret what the JSON means. We're all familiar with JSON, right? Key value pairs, it's dictionaries and lists and integers and strings. It's just a way to serialize information. So Python can easily spit out JSON. JavaScript can read in JSON. It's JavaScript object notation. It's native to JavaScript. That's why JSON actually got so popular, in my opinion, because this was often a good fit together. And so once again, this could be the language we want. This could be, no, I don't think it'd be PHP, but it could be Python, it could be C, but I'd put Python here. But this distinction is really important. It might not look very important compared to this, but it's a huge difference, right? Because now we're decoupling. We're not saying we're not specific to HTML anymore. We're just a general purpose service that returns data. We're not returning view and the data together. And so what this enables you to do is build things like this. Say, well, I have a server. It just returns JSON. Well, iOS can handle JSON. Swift can take in JSON and make your UI however it should look. So can JavaScript. So can Android and Java. So I can have one server that now handles lots of different types of clients. So now when you write your app for your TV, for get recommendations because you're Netflix, now you don't have to change your server at all. Now you just put one right here that does HTTP requests and gets back JSON, and it just figures out how to interpret. So all the data processing is happening on the server, but the viewing part of how to display these thumbnails, how to show the recommendations, how to make it all look nice is happening locally on the client. And this is pretty ubiquitous. A lot of pages use this. I was just looking for my own interest. The church's website uses this. IKEA's webpage uses this, which I'll show you in a second.
So, good question. So, what is the JSON saying? Is it pointing to?
Yeah, that's a good question.
It's not the render information.
Is it HTML inside the JSON?
No, it's the whatever data you need to get to. So you could have returned your collapse state of which menu items should have been collapsed, and so maybe there's an API call for that.
How does the browser know how to render that JSON?
Well, the JavaScript interprets it.
Oh, okay. The JavaScript.
So it's the bridge between.
So if I'm Netflix, I write the JavaScript that knows how to turn that JSON into my web page.
Exactly. Yep. Or your iOS app that knows how to make it, show up on the.
I see. So different front end developers, or maybe the same front end developer, is going to take some common JSON data and render it in lots of different platforms.
So rather than have multiple servers that for each service, you now have one server that is all talking its common API that then each individual front end can then interpret that data. I'll show you an example in a second.
JSON's ASCII, right? So it can be kind of big if you're doing some files. Is there like compression or anything they do to help that?
Well, HTTP will compress things for you actually by default. There's a way to set that up in the headers. There are much better formats than JSON. If you're really sensitive to that, then yeah, you can use protobufs and all sorts of different things to make it a lot faster. But there's a lot of good advantages of JSON, debuggability, readability. So, and often we're not like in high performance needs, but if you need it, then you can switch that out for sure. That's a good question. So yeah, okay, good.
Is there a reason why things like most web languages and such used in web are like passed in human readable formats?
Yeah, that's a good question. I don't know 100%. You know, I haven't created one of these things to really know, but my guess is, without going too much into the details of networking, in this kind of, when we're dealing with this, we're at the highest layer of the networking stack, application layer. That's where humans are debugging it, and we care more about readability. Has better value. So something that maybe is a couple more bytes of data, but is way easier to debug might be worth it than something that can save you a lot of data, but is like impossible to figure out and debug. So I think just because humans are the ones writing this, it's easier just to choose things that are human readable, and ASCII is human readable. And so it just works out better. Of course, there's something stopping you from switching to something more performant, but that's often what we choose. I think it's just a human, we're the weak link.
So is the JSON file, because the browser, when it's submitting the HTTP request, doesn't really have the JavaScript for that particular website, right? So is that passed in through the JSON file, or?
No, okay, so let's complete this loop because that's a really good point. Anticipate that. So this is what it would really look like. Is you would do initial bootstrapping to get the HTML and JavaScript, and then there's JavaScript would start executing and say, oh, I need to get the recommendations from Netflix. Let me then do behind the scenes a request and get back to JSON and then put those thumbnails where it needs to go. All
Or like when you click on the URL, it gets all the files, HTML, and JavaScript that it needs, and then it can submit its own HTTP request.
exactly behind the scenes, yeah. So, and hopefully to make this much more sense, let's do an example of that. Let me see. So I don't know if you remember, some of you might not have been here. I talked about this web crawl I did to figure out if the IKEA couch was in stock. You remember what I'm talking about here? My wife wanted a couch, and so she challenged me to write a thing to parse this page and figure out if it's in stock. It is in stock, as you can tell. And so what I had to do is I go to this page and say, well, how does it know it's in stock? Let's refresh it. Can we tell it here? One interesting thing already is we can see things dynamically happening, right? I loaded the page, but it doesn't show me right away. It's what's happening is behind the scenes, JavaScript is going on and saying, well, let me check to see if it's in stock. And then it, sometime later, it shows me it's in stock or out of stock or available to pick up. So there's definitely dynamic things happening here. It doesn't, not like it came all at once, it came in chunks, which is often a good thing to do because, I'm up here, I want to first see the thumbnails. So those are most important, but maybe when I get back down to here, I'm ready to look at that and it's already loaded. So let's see what's going on behind the scenes here. Lots of mess here, but let's see. Okay, network. Let's see all that gets loaded here. So let's refresh this. This is on the Chrome's web inspector. So, or sorry, the Safari one. It's a little different, but pretty much the same. So look at all the stuff that goes into making this one website. A lot of different things. 2 seconds to it. So what we can do is we can actually filter out to what was requested by the JavaScript. Is what we want to see. There's actually this helpful tag right here to filter that. This is only things that happen not from the initial GET request, but from the JavaScript running and say, okay, go get this resource, go get this resource, go get this resource. And so you start digging through this and say, well, what is all this? Okay, it's a lot of JSON. I mean, I don't know if success equals true. I don't know what that's doing. I didn't write the program. I could dig through the JavaScript, then minimize JavaScript and try to understand what's going on here. There's a lot of JavaScript here, so it's probably worth my time. So when you start digging through this, you start seeing some stuff. Cut to the chase here. Start seeing, okay, well, what's this right here? So what's happening, before I dig too much into this here, is that this page is getting loaded after the fact. It looks like it has some interesting things. It says out of stock right here. Okay, so that's good to know. It has some status of out of stock. You kind of look through this enough. You don't really see any store name. You see some kind of ID. It's okay, interesting. Go to store details. This is where caching is coming in. It already knew what that file cached was, and so it didn't reload. It's blank. So let me bring this to Chrome. Sorry, and do this again. And now I have this button enabled, so it will not do that. Okay. What's called stores. So many things going on. Stores details. Okay, preview that. So that's kind of interesting. This is telling me locations of stores. So that's kind of cool. So this is the type of thing that it returns to you. Like, hey, here's all the IKEA stores. You client side figure out what's the right store to show the person based on the location. But it just gives you back a big chunk of JSON and lets you on the client side process this. So you take this and copy it. I don't like working in here for VS Code. It's just in, run the formatter. Bam. Okay, let's look for Draper. Okay, sure enough, we see Draper here, gives us latitude, longitude. So every time you request this page, it's giving you latitude, longitude of every IKEA in the whole country. And then you just display what makes sense for you to display. It gives you the time when it's open and closed. So it's happening all behind the scenes, and the JavaScript is just interpreting this and deciding what to do with it. In most cases, just doing nothing.
Even the restaurant hours.
Restaurant hours tells you that, where is it? Down below. Restaurant hours. And most of this I don't understand, because I didn't write this. Tells you that the little kid section's closed, temporarily closed because of COVID. But one thing I want to pay attention to is, ID. Okay, that's kind of interesting. So 103. I wonder if that shows up anywhere else. Because I care about what the Draper location is. So let's go back to here. After digging through this, one of these, expand this, had kind of what I wanted. Right? Let's try this one. Let's copy this response. It's in here and format it. Okay, so let's look for 103. Okay, sure enough, there's a class code with 103. Coincidence, maybe, but maybe not. And we start digging through this and say, okay, oh look, low stock, quantity 1. Okay, so that's what's happening is it's requesting this JavaScript saying, okay, you care about the IKEA and Draper. Go back to here. You care about the IKEA and Draper. It's in low stock. You got that low stock from right here. We can then switch it to be, let's check the other store. Notice how it's not doing any HTTP GET requests for this because it already has all this information for us. So let's check it in Las Vegas. And I think I have to, it's telling us out of stock. So it's doing this all, it's all doing this client side, none of this server side because it's already got all this information. And so this is how I'm able to check all the stocks of every IKEA across the country because I'm just able to look at this one key value. Say, okay, what's message type? It's in stock, the quantity. It's out of stock. This one.
So the file's really long. It has it for every store in here.
It's 4,000 lines, of JSON to see. So it's like, is there anyone in high stock? And is this sure enough high stock? Okay, and it's got quantity 3. So that's where I discovered that for IKEA, high stock for this couch means 3. So that's not that many actually. I thought IKEA would be like hundreds. I don't know. I just thought they sold a lot of couches, but not for that couch. Is there like low stock? So anyways, this is what I mean by this. JavaScript is returning all this stuff. This image right here. The API is returning all this stuff, and it's up to the JavaScript to interpret it and put it on the web browser. What's great is if IKEA has an app, which I'm sure they do, I don't know, then they don't have to write anything different on the server side. They just have to take something that interprets JSON and displays it for them with whatever colors they want to display it with. Maybe, because I always found it interesting, they have what color caution is for the website. So that's kind of cool. Programmatically, they control the color of what caution for world stock means. So that means the front-end developers don't even have to decide what color to put these things. They can just read it from the JSON itself. So what this enables is having lots of different clients now. So now browser is a specific client. iOS is a specific client. Android is a specific client. If you write a command line utility, you can do that. If you write it for another operating system, if you write it, then you can just leverage the same server backend and just have different front ends. Any questions on that? Something else I was going to say. Let's do one more example.
I have it's a fun question if no one else has any questions. So if someone were to try to, I guess it's pretty strange to say just generically hack. Is that typically like attacking the back end, attacking the server, trying to get, data from the server that you wouldn't normally have, or?
Yeah, So where are you asking? Yeah.
It's like finding various requests you can give to the server that give you data, even though you're not supposed to have that data.
Yeah. So kind of going back to what Dr. Goes was saying is like, well, if you kind of if you figured out what the API was for this, then you can say, well, you know, it says tax year 2020. It's like, well, what if I typed in 2022 or 2022? And what if I typed in 2021? What would happen? And so if you can debug that and figure out, then you can kind of get information you don't necessarily have access to normally. The view is blocking you from that. So for example, the view is blocking you from it's only, I think, doing things with a certain mile radius from where I live. It doesn't show me what Atlanta's stock is, but it's all there. That's example. I don't know. So yeah, there's kind of things you can do. I wouldn't necessarily call it hacking, but because it's a public API, but you're requesting things that they didn't necessarily want you to request. Yeah. So definitely do that kind of stuff.
Something you don't have access to, you're more so just
Using how it's used.
giving it information to then boost it, give you where they need to stuff.
I'm trying to remember, there's a pretty high profile court. It's about this a few months ago. I can't remember. I'm trying to remember what it was, but
Is it the one in the Mississippi government with the reporter?
yeah.
Yeah, so there was a reporter, he went on like, I think it was Atlanta or Mississippi, one of those states. And he went on to, and he just opened up developer tools. And it turned out they were just parsing social security numbers and plain text and JSON.
They were giving all the information back to the client side.
Oh, yeah.
And they're like, well, it's not on the web page. And like you're hacking, like you're hacking the government site. And he's like, this is all coming back to my computer just because my web browser doesn't render it. Doesn't mean I'm doing any hacking here. Yeah, that's the one. Yeah.
Interesting. Okay, I hadn't heard about that. If you're not careful about what you give, yeah, like why is I keep giving
Security on every single.
But it was, I mean, part of it is like kind of, it becomes a little scary when you have people that are so technologically illiterate kind of making the decisions. It's like it was like, are we gonna press charges against this guy?
They
Like,
tried.
did
It
they
was
try?
a political thing, you know, because it was and the governor was personally trying to arrest the guy for.
Rather than fix the website, right?
And the guy, the reporter didn't even, he was very ethical. He said, look, I found this. He didn't release them. He said, you guys need to change, the state needs to change. It was the state website. And he was trying to tell, but they were kind of criticizing him. The newspaper was criticizing him.
Scary.
They tried to put him in jail.
Yikes. Okay.
Yeah.
Like the hard way.
He's a hacker.
Open the developer tools. He's
You
a
see
hacker.
everyone, you see the whole state employees, social security numbers.
So I was curious to see, well, is like the church doing anything like that? I mean, for all we know, the whole article could be loaded based on JSON, and you could reverse engineer that. In fact, they aren't doing that, unfortunately, but if you go here, load this. Finally, they're loading some things here. Interesting. I don't know what this is. I mean,
Language stuff.
it's really fun to kind of dig through this. Yeah, language stuff looks like a translation. So they apparently get all the translation information behind the scenes, or some of it, notifications, licensing. So yeah, right here, kind of start seeing something like what the poster should be. Okay, this is the poster image. Here's the thumbnail image. This is the source. And you can kind of start realizing how are they implementing this behind the scenes. And there's lots of JavaScript libraries for you, not just jQuery. jQuery is a very minimal one. Things like Angular or Vue, or there's a new one every week that will take this and then do cool things with it. So you don't have to write everything yourself. But this is Codex, so it's for like the audio stuff. So I think what I decided is probably to run this button right here. It's not. So I think what I figured out, I think, is that the HTML, the article itself is sent over HTML, but then this button gets populated by JavaScript, and that's what gets sent.
Video browser.
Yeah, so you can see, look, it's not there yet, now it's there. So I think it corresponds to this right here, and you can kind of start seeing like where is all the audio. So if you wanted to write a web scraper that could download every conference talks audio, then this would be a good place to start. Say, okay, well, how did I get this URL? And look, you can copy it as a curl command, which is really cool. Copy that. And then you can, let's bring a new tab, paste this curl command into it. And it gives you the whole curl command. I mean, a lot to it. It's not that much, okay? And if I run this, I'm getting back JSON. It's all minimized, but So if you run this command, it will give you back all that stuff. Let's just run it like this. Might not work.
So you could put that command in a Python requests thing and automate a lot of this.
Yeah, they're a little smart enough. They say, no, you're not allowed. You didn't have the right key. And so we had to find the right key. What key actually matters here? And you have to kind of dig through and figure out one of these, probably this one right here. I think you need this as well. This is kind of some sort of key to make sure that you are doing what we're trying to do. But there's easy ways.
Because also they can use that key to track how many you are requesting and what you and things.
Yeah, it's really cool. To use it like this, but be careful, I guess. But don't look for social security numbers, or if you don't tell anyone.
If you see them, don't tell anyone. Yeah, that's
Get
the
arrested.
lesson they taught everyone, right?
Any questions? So hopefully that clarifies what's going on in the world around you. That this is kind of what the world's become now. More and more things are saying, well, we probably want to have an app someday. So why are we just building a web server only? Let's build a general purpose server that returns JavaScript. And then when we want to build an app, we can. Or so that's what the world's moving more and more towards. But at the end of the day, all your web browser stuff is just this, rendering. Get the contents, render of the page, and wait for them to load another page.
It's always been interesting how websites fetch videos. A few years ago, you could just find like the video file for a YouTube channel and just straight up download it. And now like Netflix and all these things, you can kind of see how they are fetching different segments and have they different security keys on each segment of the video that's downloading. So I'll see how that works.
Yeah, that is interesting.
They want to keep their videos so you don't just straight up download the videos to keep a local copy.
The YouTube downloader is a constant arms race, right? Like,
Yeah, and it's interesting because if you have like Hulu or Netflix and you try to open a screen capture, the browser knows it and will blank the video as well. So there's something on that end that's detecting that as well.
Absolutely, yeah, and it's operating system level server.
I've noticed that on my phone lately. If I'm on certain tried to screenshot something in my banking app and it wouldn't screenshot. It was just black page, yeah.
Just imagine reconstructing a video, one frame at a time. Taking screenshots.
I mean, I have fun with my FPGA,
That's your homework.
HDMI in, HDMI out, and I can just steal everything off that.
There you go.
All you have to use is like
Isn't there HTTP on it? The copyright protection stuff over the HDMI stream?
Well, it's DVI. So in the FPGA, it's DVI, it's raw video stream. It's not actually doing the HDMI protocol. So it looks like a monitor. And so you could just capture it.
Yeah, but that's the whole point of HDCP is even your monitor has to be HDCP compliant before they'll send your Netflix video to your monitor. You can't watch it on old monitors and things.
So maybe if I try to watch it, it'd be blank. But you can also pass the information because it's just an I2C.
I mean, that was a
You can
very
just pass the I2C information from the monitor
Yeah.
over the FPGA.
That was a big deal when somebody cracked the HDCP keys, right? To intercept a HDMI stream. You definitely can't do that out of the box.
Mhm.
There are people that have done it, but yeah.
Okay, so your homework is to go do what I just showed you. Go explore, go splunking in the web and find interesting stuff. Build your own website with Kadum. That's a fun thing to do, get experience with that.
I was just gonna, if you could pull up the schedule, I was just gonna do a little pitch here. Kind of, a lot of these questions will probably come up on Wednesday. Dr. Hansen from the cybersecurity program is gonna come and talk to us about just general security topics, not necessarily web, but I'm sure some web stuff will come up in the process. So yeah, that's new this year. We haven't done that before. So come here Wednesday and we'll, a lot of these same questions I'm sure we can answer or ask him. So.